Welcome, everyone, to tonight's meeting of the New York Technology Council. And, we are a membership organization, so if you're not already a member, we urge you to join, and even better, become a sponsor. So our sponsor list is growing. We got a new one today, so I had to split the slide in two. So I'm not going to read the names, and that's the second list. So without them, we literally would not be here. So we thank them. And I want to thank Frankfurt Kurnit for hosting us tonight. David Maman is our speaker tonight. You've got his biography in the program, which I hope you picked up on your way in. He has been active in security for a long time. I'll let him tell you more details. I believe he is now with his 12th startup. So he's been very successful in starting, running companies, and then getting them healthy and moving on to the next one. And I've heard part of tonight's talk, and it's a very interesting topic and a very interesting perspective. So with that, it's all yours, David.
Just a sec.
Yeah.
So, hi everyone, I'm David, and I will really try to make sure that none of you will fall asleep tonight. And if you have any question whatsoever, please feel free to stop me. I'm really into keeping an open conversation and not just talking about whatever happening. A few words about myself. I started quite early. I finished my bachelor's degree in computer science at the age of 17. A year later, my master's as well in computer science. I'm originally from Israel. I've worked in a few big companies in my area, and also I started about 12 different startup companies. Most of them in information security, but not all of them. Some of them in big data, two of them actually. One of them in B2B communication, some ideas that I had with friends. And most of the time today, I'm the founder and CTO of GreenSQL. GreenSQL focuses on database security. And I think that the number one thing today that is happening, and I will try not to be in front of the information while I talk, is information and data theft. And probably any presentation that you'll see and any lecture that you'll see is talking about how come it's a big problem, how come it's a breach, but I just want to mention something very specific. In 2011, it was quietly passed by the media, but the FBI have announced something really interesting. The FBI have announced that organized data theft is now a bigger criminal industry than drugs trading. And just to elaborate a little bit about that, what's happening exactly? The biggest crime today in the United States is actually identity theft. And identity theft starts from the very basic things, like I will print a driving license with your information and my picture, and when I'll do anything wrong, I guess, and a police officer will stop me, I will show him this driving license with your information. And it gets worse and worse until it gets to the point where I'm taking loans and I'm taking a mortgage from the bank using your information, and the debt actually is on you. And in the United States currently, about 900 to 1,100 identity thefts are successfully every day. So we're talking about a huge industry. And the main thing about it that if in the past, if I wanted to actually exploit, let's call it exploit, a successful identity theft, I had to probably go to your home and wait outside, and when it's available, just to steal mail that you get to your home, and with time get enough information to generate this identity theft. But today, when information is so available broadly, so by any company is holding this information, and actually a kid, and I'm not just saying that, a kid can steal 10,000 records that will be enough to generate thousands of different identity theft within a few minutes, it's becoming wider and wider, and the phenomenon is actually growing. Some of the big names that you can see in front of you now are actually companies that invest a lot of money on information security. They have extremely talented people working in information security and making sure that their information will be safe. But as time passes, we can see that it doesn't matter almost who are the names that are in this list are suffering from huge data breaches. And it actually gets to the point that it's almost not a question of if, it's a question when you're next. And it doesn't matter how big of a company you are and how much money you spend on information security. That's a really big claim, but I will try to explain what I mean. If in the past, company could really try and I think, set a border defining what is internal inside of the company and what is external, connected to the internet or connected to other companies. Today, everything is connected. Any computer, any smartphone that is connected to Facebook or the internet or any part of remote or, I guess, remote sources of information is part of the entire world. So if in the past companies could actually set a perimeter and said, this is our perimeter to the internet. Until this point, everything is secure internally. There's no perimeter today. Once you just run your Skype on your computer is now a member of a peer-to-peer network actually that people can take advantage of. If you download videos, if you view content which is outside of your network, your computer is now part of an external network. So the entire perimeter definition have completely mixed. We're all connected in a way. Many times it's beyond our control of any kind, and people are still not getting it. But some of the names here, like Adobe, like Visa, like LinkedIn, like companies that live because of their security teams and have endless attempts of attacking them, have suffered some of the biggest breaches that you can imagine. And it's not getting any better. Those are, by the way, just a few highlights. If you'll go to Google and you'll just type databreach.org, you'll see a full list of almost each and every one of them. And I think this brings me directly, in order for me to explain the motivation of not just database security, but mostly data security. So a lot of times people keep on saying, I don't have anything important in my computer, on my database, or on my resources. But the thing is that today there's a full threat economy. And when I'm saying threat economy, it means that a lot of huge organizations, and I'm talking today, it's billions a year, nothing smaller than that, that sponsors an extremely sophisticated teams in order to get your information. To get your information, it starts with getting to your home computer, getting your eBay account, your PayPal account, your CV, any information that they might use and they might sell. And it's getting up to the point where they actually attack your organization in order to steal as much information as possible. And as I mentioned earlier, if there was a perimeter so I can make sure that no one can access my sensitive information, today it doesn't matter. Just to give you one simple example. In any company, for example, there are IT guys. The IT guys many times have access to all internal resources. They actually configure the security mechanisms, they configure the IT mechanisms, and so on. They are one of the major, I think, targets for attackers today. And if in the past it was really hard to find out, now I'm just going on LinkedIn, finding the names of the IT guys that work in your companies, I'm adding them to some groups that they would actually like, and sending them a malicious link. That's what it takes. And some of the biggest, by the way, information security firms that you know, from RSA to McAfee to Symantec, they are the company that are suffering the endless amount of attacks, and all their IT guys are under constant attacks. Because once I'm able to gain control of your IT guy computer, I can get access to everything. I probably have the username and password to get to the domain server, to the file server, to the ERP, to the CRM, whatever. All resources are actually managed by the IT guys. And then there's a lot of different organizations that sponsor extremely smart people that will provide them the option to get to your information in order to trade it. I guess you all heard about the target attack. And the target attack, it was an extremely sophisticated attack, by the way, that was not something simple and stupid like SQL injection that we will discuss very soon. But this was a much sophisticated attack. People actually have crafted a special code that runs on the point of sales that they have in their stores. Meaning anytime a credit card passed through the point of sale, someone have copied this information and sent it to somewhere else. But the thing is today, even though it was so publicly actually noticed by the media, the CEO was fired, the CISO was fired, actually a few different C-level executives have also been fired because of a data breach, just to understand how big of an issue it is. But today you can go on the black market, which everyone here can access from his own home, and buy those records from Target. And no one actually even tries and can actually stop that. So all this information of 110 million customers of Target are now on sale. What I'm trying to say here that if in the past it was just about defacement of website, and it was someone who was trying to brag, I hacked your website and put there a picture, today it's not the deal. Today there is a full financial, well, I think strategies in order to steal your information without being known. In Target, it was running for years. In other companies, it's running while we talk. That's how of a big issue it is. And even though I'm talking here about web application attack surface, but this is something very important to understand, the attackability surface. I'm going to go through into a little more explaining in a few minutes, but many times you are not the target of the attack. Your customers are. Even if I will try to attack you through your website or through some internal resource, I don't care about how much information you might have. For example, if I'm attacking LinkedIn, so LinkedIn have a huge database, but the information of any user that uses LinkedIn is much more, I think important for me. And so goes to many other types of attacks. So it's really important to understand that many times attackers and attacks are not targeting the companies themselves, are targeting actually a lot of users who use the other resources available on those platforms. And the main thing about here that even if you secure your architecture and secure your application and secure your databases, it doesn't mean that your information is only located in one place and you can actually secure it. Any IT infrastructure in any big company, and even actually an SMB company, is actually replicated to a lot of different databases and a lot of different locations inside of the infrastructure. And even if I'll spend a lot of money on securing the core database, it won't help. And this was actually in the list that I shown before, in one of the biggest banks where they secure their core databases and they spend a lot of money on making it as secure as possible. One of the smallest databases in one of the branches had a replication of a few million customers. And this database, who they, I'm not sure forgot, but it was in a lower priority in securing it, was actually breached. And that was quite enough for the attackers. So we're talking about many times about databases and the data stores, and I think it's really important to understand the who's using the database. So any information, once we have an active application and dynamic application that stores and saves information, have eventually two types of connection. The user-based, meaning any IT guy, any DBA, any person which have the knowledge to directly connect and work with the database. Many times, it's just a few people in the company and nothing more than that. The other types of connection is any application that runs inside of the organization that have the option to retrieve, update, sometimes actually even configure a database, but this is what's called an automated connection. Once it's been configured, the application using the database as a data store, and all the information is stored inside of these databases. And talking with a database, I'm not sure how many of you are technical, so I'm not going to go too technical, but talking with a database, it's much more complex than people think. Because many times people think there's a language called SQL, and talking with a database is running a SQL query to the database will reply. But there are actually 3 different layers of negotiation with the database. And attackers have learned how to take advantage of those 3 layers. Many times when DBAs or developers even connect to the database, they only see the let's call it the upfront level of communication where they actually type a username, type a password, are able to query the database and to retrieve information on demand. The thing is that there are 2 different layers, the database application protocol and the connection layer, that got nothing to do with this type of negotiation. And those types of communications are actually more vulnerable than the SQL syntax itself. So attackers have learned something quite at the beginning in order to understand the attackability surface. And I think one of the most important things that I'm going to talk about it today, and I would love you to understand, is trying to see the bigger picture. An attackability surface of a system, any system, a database, a CRM application, ERP application, whatever. When we're trying to see the bigger picture, it's important to understand the entire component. Many times you'll talk about, for example, in this example, I'm going to talk about the database. A database is an application, an extremely sophisticated application. Actually, it manages its own memory, it manages its own file system writing, it manages its own CPU actually executions and execution plans and whatever, but it's still an application. And this application runs on an operating system. For example, today's attacks, when people steal information, any of the following attack vectors can lead to a successful breach of your entire information. What I'm trying to say today, more than 90% of data breaches, people are not attacking the database application itself. Any third-party application, any application that connects to the database, any component that runs inside of the operating system are the main target of attacks. And I'm trying to just to map here in order to explain you what it means attackability surface. Any vector that might lead to a successful breach, which is part of the infrastructure, trying to see the bigger picture. So those are, by the way, just several attack vectors of the Windows operating system. So if this Windows Server operating system is running my SQL Server, my dynamic CRM, or any application that I might have, any of the following attack vectors will lead to a successful breach, and someone, by taking advantage of those attack vectors, will be able actually to steal all the information from the server. And more annoying than that is that even if I enable logging and auditing as part of my database application or any application, it will not even alert me that someone was successfully stole the information from my database. And talking about databases, something interesting have happened, I guess, the past 15 years. If at the beginning, much before open systems, everything was consolidated. People here might remember still the VMS world and the entire, let's call it the legacy of the closed world. Everything was consolidated. And then actually the operating system have opened, Windows Server went out, Unix, Linux, BSD, and many other operating systems, and they started to run those core databases. Oracle started, right after that DB2 and Informix, and then Teradata and all those core databases. But during the past 15 years, actually organizations started to be much more dynamic. The number of applications offered to their customers and to their users have exponentially grown, meaning they started actually installing endless amount of database in their infrastructure. To give you some numbers, probably the biggest financial organization in the world, in 2001, they had 41,000 databases worldwide in their infrastructure. At the end of 2013, they have 187,000 databases in their infrastructure. And the number of customers, by the way, stay the same. So just explaining what's happening when it comes to endless amount of database running in your infrastructure, it means that endless amount of information is being actually stored in a lot of different places. And managing this kind of information is almost impossible, I think. The past few years, there's a huge migration to the cloud. So you hear a lot about the cloud. The cloud is a huge buzzword. And when most applications move to the cloud, so the data itself also start migrating to the cloud. And there are two approaches when storing information in the cloud. First of all, infrastructure, meaning you install your database server on the cloud, you set your information there, and you store it there. The second type is database as a service, which means you can purchase a ready-to-use database, Microsoft SQL Azure, Amazon RDS, VMware is going to announce it this week, Cisco is going to announce it this week. Each and every major cloud provider is going to provide database as a service. The overhead, when you're not the owner of the database, is dramatically reduced. You don't care about update patches, about installation of software. You don't care about high availability. You don't care about, well, all the benefits that cloud provide us. And with that, of course, information is getting, well, information will be stored in a lot of different places that we cannot truly control. And I think the cloud brings a huge added value to companies. But with that, a huge headache as well regarding controlling where truly the sensitive information is stored. According to several different actually analyst groups, in about 3 to 4 years, 70% of the database that will be sold will be database as a service. Everything is going to be in the cloud, we like it or not. That's how the market goes. So a lot of questions are actually popping up when we're talking about what exactly am I supposed to secure when I'm securing a database? What exactly, which questions are being asked? I think I can sum it to 3 main questions. First of all, where is the sensitive data? I can assure you, if you talk to a DBA, he have no clue. He can tell you the structure of his schema, he can tell you how exactly the application connects to the database, but he have no clue, and to be honest, why should he? Where is the sensitive data is located? The second thing is, who have management and management control and management access to the database, and what exactly they're allowed to do? And many times, hi. Everyone here introduced himself and talked about his hobbies, so if you don't mind.
My name is Mike Comerford. I'm from Chicago.
He's kidding. Right?
I'm kidding, Mike.
Hobbies are illegal. That's why I'm trying to find out.
Perfect.
So, the second question is about administrative access, and that's a big question and many times being referred as segregation of duties or separation of duties. How can I make sure that even though my DBA that I trust and I love and I cherish will have the option to manage the database, but he should never have the option to see sensitive information? You remember at the beginning of this talk, I talked about how come IT guys are the target of any sophisticated attack today, so the DBA it's even worse. Because the DBA have all the credentials and all the access level to access the database itself. And if I'm able to find on LinkedIn the DBA of any company probably that I'm interested, and I'm able to run a sophisticated attack in order to take control of his computer, I have access to all the database inside of the organization. That's why it's not about not trusting the DBA. It's about setting rules, and actually several of the different regulations that a lot of companies have to comply with, and it doesn't matter if we're talking about HIPAA, FISMA, PCI DSS, Sarbanes-Oxley, and so on. In 2014, for the first time, have moved from what's called monitoring approach of databases, which only required database activity monitoring, have moved to enforcive security. And most of them are now requiring segregation of duties. So they can truly make sure that the DBA should not have access to sensitive information, and any part of other people that have access to the database will not be able to run administrative commands to the database. And this is a really important part because the last and third question that is being referred from those questions that popping up when we're talking about information security challenges of securing your data is, what about a third-party application? If I have a web application that is connecting to my database, because this is the service that I provide for my customers or from our users, people executing SQL injection command are actually able to retrieve everything. Most of SQL injection command won't be able to run if I remove any administrative command of what I'm actually providing them to use my database. And this is just a short list of the different regulations according to the company and to the vector of companies that you're working in or consulting to, but each and every requirements is actually talking about a really wide area of requirements, from where exactly I place the video cameras at the entrance to my office, to which antivirus I'm running on my desktops, and it gets to the database itself. And those are actually just a few examples that we can take a look at regulation as a hassle and as something that annoys most IT guys. But on the other hand, those things are really helpful. So getting the benefits of those regulations can really help. Everything is summed up to PII. PII, personally identifiable information. Any information that is considered sensitive. So one of the most important things is detecting and scanning where exactly this sensitive information is located. So you can buy quite a few different applications that will go through your database and will help you to detect where exactly the sensitive information is located. It's extremely surprising. In GreenSQL, we have a few thousand customers worldwide, some of the biggest insurance companies, some of the biggest telecom companies. It doesn't matter how big of a company. Talking with the DBAs and talking with the IT guy, they have no clue where sensitive information is located. And it's always still surprises me actually to see that companies that have a huge IT team, I'm talking about thousands of IT guys, and no one truly have a clue where the sensitive information is located inside of the infrastructure. And once you know where the sensitive information is located, you're able actually to go through the next step and enforce some sort of a policy. By the way, it doesn't matter if you're talking about the database on-prem or in the cloud. The responsibility is the same. And the same, by the way, goes with the different regulation. Once you own the system, it's your responsibility to know exactly where the sensitive information is and to make sure it's secured. In some regulation, by the way, it's much more serious, let's put it that way, like HIPAA, if we're talking about the health and the healthcare industry. And this brings me specifically to SQL injection. SQL injection, one of the most known attack that is available for the past, since 1999, 15 years, and still #1 threat on organization. The thing about SQL injection, that even though it's directed to your database in order to steal information from your database, it's actually not attacking the database. SQL injection is actually attacking an application that have connection to the database. And using this type of connection, and by the way, it almost doesn't matter which application you use and which database you use as part of your solution, SQL injection provides an attacker the option in 1 minute to gain a full control on your database. And well, it's illegal to run SQL injection attacks, but no, we won't do that, no. But trust me, go to Google, write SQL injection, and you'll see dozens of different tools that will provide you the option to run automated SQL injection without even knowing what is a database. And those tools will actually map an application and will find the SQL injection breaches and will take advantage of them and will provide you a full access to the database. That's how easy it is. That 14-year-old kids are stealing information from, you won't believe, but the biggest databases you can imagine in 2 minutes. And just a few things about SQL injection. If in the past it was only about stealing information from the database, and stealing sensitive information actually, today SQL injection have actually, let's put it, grown in order to get interaction with the operating system. Meaning, if I'm able to run a successful SQL injection on your website and steal information, I can also gain control of the operating system of the database server. And many times, what sits next to the database server? The file server or any other servers that I have in my data center. So using a successful SQL injection attack, people have actually started to take it much more seriously and have started actually gaining control. And just an example, you know, at the end I'll show a short demonstration about what I'm talking about just to show you how easy it is. But just to give you a clue about how many times it's happening every day. today, according to the statistics of Symantec, of McAfee, there are about 7 billion SQL injection tries a day. And it's not that 7 billion people are sitting and trying to attack. SQL injection is now part of an automated worms, meaning worms are trying to map your websites and trying to find vulnerable links and try to take advantage of your web application in order to steal your information. And this is an automated process, meaning that the chances are that you have been under, well, successful or unsuccessful attacks many times. By the way, 90% of the times, people that suffered from SQL injection attacks doesn't even know about that. That's how of a big problem it is. And I just want to take it to a little bit more scary part about how, until now it was funny, yeah, I know. But until of how serious it is. Because many times people are not aware of the big problems. And there's a different lecture that I actually did that I call it the blind spot of information security. What you cannot even mitigate if you're interested. So all of us using computers or servers, and inside of those computers and servers there are hard drives. And inside of those hard drives, goes without saying, we're running different operating system, but much beneath the operating system, there is a small, very, very small operating system of the hard drive itself. For example, if I'm running a SATA hard drive, it's got a very small operating system that runs the SATA controller. And using a few, well, it's about $70, I can build, anyone here can actually build a box that will provide him the option to rewrite the SATA operating system that runs inside of the hard drive. Meaning, there's no, by the way, solution for that today. Companies add thousands of hard drives to their infrastructure on a monthly basis. Thousands. And none of them is actually aware that you're able to rewrite the tiny, tiny small operating system that runs on the hard drive and actually add there your own code that will even take advantage whenever you're interested. And organizations have no clue. And just to give you an example, using a SQL injection attack, you can actually run the code that you've added to the hard drive. So maybe it will be a little bit too technical for you, but the thing is that I'm able today to initiate a command and write to a specific location inside the hard drive that will initiate the code that is running inside of the hard drive in order to start copying information, for example, or start deleting information, whatever I wish. And why exactly I'm talking about this specific example? Because this is a true blind spot. No one have a solution for that. No organization is actually even got it in their plans. And just a tiny something, where are most of the hard drives are being manufactured? In China. And probably 93% of the different appliances we use are manufactured in China. And China, it's a government thing, of course. Governments are actually adding code to a lot of different appliances that are manufactured in China. For example, if you buy a printer and you connect the printer to your network, you truly have no clue what can run on a printer. But a printer is a computer. And you cannot install antivirus on a printer or format your printer. But the code that is actually added by the different manufacturers is full of interesting things. Let's put it that way. OK. So many times in the world, I have only 40 minutes, so we'll start finishing quite soon. So many times when people are talking about security, many times they're referring to Web Application Firewall. Web Application Firewall is the entity that knows how to secure web applications. And there's a lot of different vendors in the market, but it's a huge difference between securing a web application and securing databases. Databases are being used by many other different types of connection besides a web application. And I think to try to sum up the scope of securing a database It starts, first of all, with the application itself, about mapping who can actually use the different resources. It gets to the point that I need to know the exact application, because I can use a legacy application that I have running inside my firm for the past 15 years, and even if I'll install the latest database, even SQL Server 2014, it will still work because of compatibility support. But the different driver that provides the access to the database is vulnerable to endless amount of attacks. So I have to know the exact application list that is about to use the different database and the different resources. And then we get to the network layer. How can I truly map the number of drivers, the versions of the drivers, the different variations of the drivers that are about to connect to the data? And then the operating system security, again, it goes the same to any database and any application. And then we get to the file system itself, where exactly the files are being stored inside my file system. And the most important part, the information itself, at least the sensitive information. The metadata and the configuration level is less important. The sensitive data is extremely important. But when we're talking about database in the cloud, a lot of different layers are not under our control. Meaning, what eventually remains is the option that I have to know where is the sensitive data, how can I mitigate any unauthorized access to this sensitive data, and how exactly can I control it. And it was 40 minutes, as you requested. Yes, you're just saying hi, or?
No, I have two questions, but I'll start out with a really simple, obvious one. If you're really paranoid in a large company and you're worried about the firmware and the disk drives being tampered with, could you be preemptive and actually, as soon as you take it out of the box,
Rewrite it?
rewrite
Yes, you can.
Yeah, sure. Okay.
No company does that, I can assure you.
Well, okay, just as a theoretical question. The other thing is, it's my impression that, and I think this is what you kind of already said, that in a cloud computing environment, if, say, you're a company and you farm out your operations to a cloud computing service, that basically that is fundamentally insecure. That because you're trusting them to actually maintain, whether it's virtual or physical server, that
Everything.
Right. That, for example, a rogue sysadmin on that side could, even if your system is pretty well hardened, extract encryption keys by doing something like a core dump or something of that sort.
There's a question order.
Could you repeat the question?
Oh, okay. Right. Is cloud computing fundamentally insecure as the simple version of it?
Any cloud vendor will say, of course not. They are secure. But the thing is that you are part of an endless group, that everything runs eventually the same versions and the same everything. For example, I'm not sure you heard about there was the Heartbleed attack recently in shellcode. 90% of cloud architectures are still vulnerable to that.
They have a
They can't do it overnight, okay? Because it's huge architecture. Can you even estimate how many servers Amazon is running? It's in millions. You can never upgrade everything like that. It's a matter of months and sometimes even years to take control of that. You know, Akamai, when they reached 16,000 servers, they got to the point that they couldn't even restart all servers on the same day. And now they have something like 190,000. Okay, so in this kind of dimensions, even if you have a plan of upgrade and you have a plan of testing, of course, before you upgrade, it takes a very long time. And you have to wait, of course, because you cannot control those types of elements. Yes?
Is there any sense of information fatigue with bad guys? Because obviously, when it's well documented that on our side of the fight, we feel overwhelmed by the amount of information that we're doing the proper things with. Are they sophisticated enough to go after the stuff that they want, or are they drowning in information?
Well, it's interesting to see that in the black market, besides the option of buying and offered information, you can actually request specific information. Meaning, if tomorrow I would like to get the information from, just an example, of course, yes, but what runs on the CEO computer of Ernst & Young, this is a request, and I need to say how much I'm willing to pay, and if someone will take this task, he will get to the computer. Okay, this is just a tiny example. But those are the things that are actually being traded today. Okay, so targeted attacks, this is the main thing today. Not about just getting to endless amount of information. Yes?
One of the things you mentioned was not knowing where the data actually was.
Yes.
So that brings the question of what country is it actually in?
Which is almost today impossible to truly know when we're talking about cloud architectures.
They claim, if you go to have an Amazon account,
Yes.
they say your servers are in our data center in Virginia or something.
Yes, you can, exactly. This is, by the way, came from regulations. Because, by the way, each state also got their own rules. And there's a really, actually surprisingly good act that called, it started in California about 4 years ago, the Information blah, 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 blah Act. I'm sorry, you can Google it. And this actually refers to a very important fact that once you know where the sensitive data is, it's your ass. I'll try to summarize, yes. It doesn't really say ass in the act, yeah? But the thing is today that a lot of companies, even if they have an idea where is the sensitive data, it's not really in their initiate plan just to take control of it. And that's why, so what started happening once this act started to be approved in different states, company says, I don't want to know. That's interesting, but that's another approach to, sad, but true. Yes?
I don't know if you're qualified to answer the question, but isn't there an issue if the data is stored in China or India or some other country as opposed to, you know, this country?
So it's an interesting question, but what exactly it means stored? Because if you have customers and clients that needs to use this information that are located in China, and if your service is extremely slow serving from Virginia, you won't have those customers. And any customer, any company like Akamai or companies that store the information closer to the end user, if you won't use those services, you won't have business.
No, but I guess it may be outside of your realm of knowledge, but it sounds to me like a legal question of
Yes.
who owns the data if the data is on a server in another country.
Yeah. As well, this is also an important question. That's why the entire virtualization world by VMware started it. Actually, Zen started it, but VMware right after that followed. VMware and Zen and actually hypervisors of multi-different vendors are actually providing you today the option, even though it's running on a separated hardware that is located in China, the keys that will allow the information to open and even the operating system to start are managed by you. So it's still owned by you. This is also something that, but that's a really wide level of questions that are being asked now.
David, is there any significance to green in front of the SQL?
When I started the company, actually, I started it as an open source project in 2006. And back then, a lot of VCs used to put money in green technology. So I said I put green, and no question will be asked, yeah. No, the thing about green, the thing about green SQL was about that this query is okay. Got a green light to go forward. And of course, getting money. Yes?
You mentioned the Heartbleed virus, or the
It's not a
vulnerability.
virus.
Vulnerability, yes. So a lot of companies have had to contact their vendors.
Yes,
because
in
of
order
it,
to get
and
updates.
to get some reps and warranties about have you applied all patches and fixes, and yet in your presentation you talk about attack vectors and how even if you do apply the fixes, the patches, etc., they can still find
A different
another way
type
in,
of vectors, yes.
right? So what's the point every time when there's an attack?
What's the point that you close your door at your own?
You know, but
No, I'm seriously asking. Because, you know, a thief can get through the windows, can get through the chimney, can get through a wall that it can break if it's a thin wall. Exactly. Because it just, it just increases the chances of your survival, I guess.
Mhm. And if you're on the vendor side, what are you actually representing? And more, what are you actually representing when you say yes? You know, I've applied all patches and fixes, yet.
That's a really wide question because a vendor, that's really interesting about which vendor. Because if you're just a software vendor and this software runs on an operating system, so your responsibility is very narrow, okay? And you can be in charge of the specific code that you provide to the customer. On the other hand, think about the different black boxes that vendors are providing. When you take a box and stuck it in your data centers, of course it's run an operating system, and many times the vendors don't care and maybe don't just pay enough attention about the security level of the appliance. just their code that's running on this appliance. Meaning, for example, the hard lead attack, of course, that attacks a specific SSL negotiation, and you're able to get any appliance that you store and install in your data center runs an SSL connection. About 75% of them were vulnerable to that. More than 50% of them haven't updated it yet. Meaning, attacker that gets to your network is able to find many of those. And also go to the shellcode, the recent shellcode attacks and the OLED attacks. And it's on a daily basis. For some reason now the media publishes that, but it's happening on a daily basis for the past 12 years of different vulnerabilities. You know, there's about 45,000 vulnerabilities just from the past decade. On how many of them have you heard? Some of them, by the way, are much more malicious and much more widely used than the hard lead. Yes.
Okay, so you talked about that there's an actual operating system on the hard drives and on the devices.
This was just a tiny example.
I understand. But using that as an example, and that the fact that a majority of these devices are made in other countries.
Yes.
Some of which may not have, or may have
Goodwill.
ulterior motives or whatever.
Yeah.
I think you're saying that we're at much higher risk than we realize.
Of course.
And that any of the devices out there that all these companies are using, that we're using personally, whatever,
Just because
are
you
at
mentioned
risk
that.
of vulnerability and attack by the country or the government or whatever.
Just one sec, exactly.
Yep.
I just want to show you something specific.
Mhm.
Those are just some fun things. Okay, so I think that regarding specific hardware that we just mentioned, a very interesting question is what's being referred to as the Chinese Enigma. Okay, and endless amount of different appliances that we use, which we can refer them as a smart appliances. They have a network connector, a Wi-Fi connector, any kind of connectivity. It's eventually running an operating system. And as part of this operating system, there's endless amount of backdoors that is being installed on those systems. And just to give you the most simple example, even a specific case study, let's take, for example, just one sec, printers. Using an HP printer today, which is probably still the most common printer in the world, okay, today you can buy tools that you can install on printers. Meaning you can actually install a network scanner, vulnerability scanners, a full tunnels into organization that runs on your printer. All of them, not all of them, but many of them have been developed in foreign countries, let's put it that way. And organization even think about putting a printer on a separated network? No. Oh. Okay. Okay, that's the answer. And you can put everything on a printer today. You know, this is, think about a Trojan horse. This is a real hardware Trojan horse that can sit anywhere as part of your infrastructure. Okay, so that's just a tiny example to explain you how big of a problem it is.
So how, I guess the obvious next question is there anything we can do about it?
Yeah, of course, there's no 100% in security. Doesn't matter how much money you got and how much money you will spend on getting to be secured. But you can increase the chances, as I mentioned before, of survival. You don't seem too happy. Thank you very much. Yeah,
I'm sorry.
I forgive you.
One more question. Threaded through your conversation was sort of an implied question about identity governance, like making sure that you mentioned up front about the theft of identity, and then on your threat matrix there, you probably had 6 or 7 things which were listed around poor identity management, and you mentioned the DBAs are obviously a high target.
Just an example.
Just your general thoughts and observations on how firms are dealing with identity management. Are they not?
According to a recent survey, 90% of them don't deal with that yet.
What?
They don't deal with that yet. Which means that even, and I give an example regarding the number of databases that I have as part of the infrastructure. through multiple surveys, about 23% of the databases that are running inside of an infrastructure have some sort of sensitive data. It can be just a customer's login identification, or maybe even credit cards, or whatever, for example, or social security numbers, and so on. Out of the 20%, about 2% are considered the core databases and the core center of information that companies actually invest money on securing them. So companies are going in this direction, but it's extremely slow. Thank you very much, everyone. I hope you enjoyed this session.